The question is the fourth one on problem set 5, the mixed strategy problem set. So the game is the asymmetric study date problem. I don't want to spend time explaining what this payoff matrix is, so I'll just assume that it looks like this. And then the main problem with this is the indifference method doesn't work. But as I said in class, always try the indifference method. If it doesn't work, you'll know that it doesn't work. So the payoff from R is equal to the payoff from J. So try this, and I need to suppose the second player, which is Juliet, I think chooses to go to robots with probably the alpha, and goes to EJ Pratt with probably 1 minus alpha. If that happens, then going to robots for Romeo, we'll get 2 with probably alpha, and 0 here with probability 1 minus alpha. So going to EJ Pratt will always give Romeo 0 because somehow he hates EJ Pratt. Which, well, I think is a nice library, but it's too small, so I don't go to that library as well. But anyways, this gives me this, and alpha is 0. So when you see alpha is 0, less than or equal to 0, alpha is larger than or equal to 1. In those cases, this doesn't work, so don't use this on the exam. You need to do the best response method. So let's do this. So the best response of Romeo, given Juliet playing with probably alpha and 1 minus alpha, I would get, if there's any kind of mixing, then I will, if Juliet goes to robots with any probability, then there is a probability that I get 2. Otherwise, I always get 0. So R is the unique best response. Right? Again, if there's any positive probability for Juliet to go to Robots library, then I get a positive number here by choosing R, and strictly 0 by choosing J. So R is the unique best response. They are indifferent, or I can mix between them only if alpha is 0, which means I always play J. So I mean, Juliet always plays J. So if Juliet plays J, then I don't care because I get 0 anyways. So the best response of the other guy, Juliet, with Romeo mixing was probably beta, and 1 minus beta is like this. So I either go to R or I go to J, or R or J, or kind of mix. So it's always, you see, it's always this format. Let's just solve some algebra. So if I goes to R is better, when is R better? So it's the payoff from R, which is this, is better than the payoff from J. So let's use a different color. So this and this. So if I go to Robots library, I get 2 is probably beta, and 1 was probably 1 minus beta. So 2 here, because the other guy is playing probably, it was probably R, so I get 2 is probably beta, and 1 was probably 1 minus beta, is larger than 1 was probably beta, and 2 is probably 1 minus beta. Then we simplify this. This is what? So 1, so 2 beta is larger than 1. So beta is larger than half. So when beta is larger than a half, I go to Robots library. When beta is less than a half, I go to EJ Pratt. So when it's equal, I go to either. So now drawing the best response function, let's use black. Yeah, I probably should use the color orange because it's new black, but anyways. So where was I? Yes. So drawing this, I'll use the color blue. And when beta, so this is beta, this is alpha. So when beta is less than a half, so when it's equal to a half, anything is okay. So it's like this. When it's less, it means I need to go to J. So J means alpha equal to 0. Again, alpha is the probability of going to robots. So J means alpha equal to 0, and 1, I mean 0 means J, and 1 means R, so it looks like this. In the original version I posted is wrong, so now I'm fixing it. So I'll use red to draw this. This is easy to draw because when alpha is 0, I choose J for sure. So J means it's beta equal to 0. So when alpha is equal to 0, then I need alpha equal to 0 is this line, and anything is okay. And when alpha is larger than 0, then I always choose R. Choosing R means beta is 1. So beta, again, is the probability of choosing R. So I get this whole thing. So suppose this is 1 here. So now this part is the mixed strategy Nash equilibrium. There is one pure strategy here. Pure strategy Nash equilibrium. Of course, there is one here as well. This one is pure strategy too. So we still get 3 different ones, a bunch of mixed ones, and 2 pure strategy ones.